In the depths of space, 1.5 million kilometers from Earth, the James Webb Space Telescope maintains its silent vigil, its golden mirrors collecting ancient photons from the cosmic dawn. But in recent months, Webb has detected something unprecedented. Something that has sent ripples of concern through the global astronomical community. An object of unknown origin and composition is moving through our solar system, following a trajectory that will bring it into the inner solar system within the next several years. The discovery has prompted an unusual response from the world's leading space agencies and almost complete silence that has left the public unaware of what may be humanity's first genuine encounter with the unknown. The story begins with routine observations conducted as part of Webb's Deep Sky Survey program, on a night that seemed no different from thousands of others. The telescope's near-infrared camera captured something that should not have been there, a faint but distinct infrared signature moving against the background of distant stars, and like the predictable paths of known asteroids and comets. This object exhibited characteristics that challenged every existing model of solar system dynamics and composition. Initial attempts to classify the discovery using conventional astronomical databases failed completely. The object's spectral signature matched no known material compositions. Its trajectory suggested an origin from the outer reaches of the solar system, yet its movement patterns defied gravitational models based on known planetary influences. Most disturbing of all, the object appeared to be undergoing subtle but measurable changes in brightness and spectral emission as it moved closer to the inner solar system, suggesting either internal activity or response to increasing solar radiation unlike anything previously observed. The first sign that this discovery was extraordinary came not from press releases or scientific papers, but from the absence of both. Typically, Webb discoveries are announced with great fanfare through NASA's extensive public outreach programs. Press conferences herald new images of distant galaxies, detailed analyses of exoplanet atmospheres, and insights into cosmic evolution. Yet this detection, made months ago according to leaked observation logs, has been met with an unprecedented wall of institutional silence. The discovery Dr. Sarah Chen had been analyzing Webb infrared data for over 2 years when she first noticed the anomaly. As a senior researcher at the Space Telescope Science Institute, she had processed thousands of observations, cataloging everything from distant quasars to nearby asteroid families. The routine had become almost meditative: download the data, run the automated processing pipeline, review the results, and follow the observations in the appropriate databases. But the observation from May 15th broke that routine completely. Among the background stars and distant galaxies, a single point source showed characteristics that made no immediate sense. The object was clearly within our solar system based on its parallax shift across multiple observations. Yet its infrared signature was unlike anything in the extensive catalogs of known solar system objects. The first red flag was the object's temperature profile. Most asteroids and comets exhibit predictable thermal characteristics based on their distance from the Sun and their assumed composition. Rocky asteroids reflect sunlight and radiate heat according to well-understood physics, while icy comets sublimate and develop characteristic comas and tails as they approach the inner solar system. This object displayed neither behavior pattern. Instead, Webb detected a complex thermal emission spectrum suggesting an internal heat source completely independent of solar heating. The object maintained a consistent temperature profile despite its changing distance from the Sun, a characteristic that implied either radioactive decay, chemical reactions, or some form of active thermal regulation. None of these possibilities fit with current understanding of natural solar system formation processes. The second anomaly involved the object's trajectory. Using precise astrometric measurements from multiple Webb observations, Chen calculated an orbital path that suggested the object originated from the heliopause region, the boundary where the solar wind meets interstellar space. However, the mathematics of its approach trajectory required gravitational influences that could not be accounted for by known planetary masses and positions. The object appeared to have undergone course corrections during its journey through the outer solar system. Subtle changes in velocity and direction, that would require either extremely precise gravitational assists from undiscovered massive objects or some form of active propulsion. The former possibility would revolutionize our understanding of outer solar system architecture, while the latter would represent the first direct evidence of artificial objects of non-terrestrial origin. Chen's initial instinct was to double-check her calculations. Extraordinary claims require extraordinary evidence, and the implications of either scenario demanded absolute certainty in the observational data. She reprocessed the raw Webb observations using independent analysis software, cross-referenced the astrometric positions with stellar catalogs, and verified the instrument calibration data. Every check confirmed her original findings. The object was real. It was artificial or composed of unknown materials, and it was moving toward the inner solar system with apparent intentionality. Chen's next step was to search the Webb archive for any previous observations of the same region. Deep space surveys often re-observe the same fields multiple times over months or years, providing the temporal baseline necessary to detect moving objects and measure their properties over time. Our search revealed something even more unsettling. The object had been present in Webb's field of view for over 8 months before Chen first noticed it, appearing in observations dating back to the previous September. During that period, it had exhibited systematic changes in brightness, spectral characteristics, and apparent size that suggested ongoing physical or chemical processes. The object was not simply moving through space, it was actively evolving as it approached the inner solar system. Most significantly, analysis of the earliest observations revealed that the object's infrared signature had initially been much fainter and spectrally different. Over the months of observation, it had grown brighter and developed the complex emission features that first caught Chen's attention. This evolution appeared correlated with the object's decreasing distance from the Sun, but not in the manner expected for sublimating ice or thermal emission from heated rock. The pattern suggested something responding to changing environmental conditions in a controlled, almost purposeful manner. Natural objects might exhibit chemical or physical changes as they encounter different temperature and radiation environments. But the systematic nature of these changes challenged conventional explanations. Chen knew that protocol required her to report the discovery through official channels. The Space Telescope Science Institute maintains strict guidelines for potentially significant discoveries, particularly those that might have implications for planetary defense or public safety. However, she also understood that such a report would trigger a complex review process involving multiple space agencies, academic institutions, and potentially government security organizations. Her decision to proceed with the formal report would set in motion a chain of events that would ultimately lead to the extraordinary silence surrounding what may be the most important discovery in human history. The investigation deepens ***. The formal review of Chen's discovery began within days of her initial report to the Space Telescope Science Institute. Dr. Michael Rodriguez, the Institute's Director of Unusual Objects Research, assembled a small team of specialists to independently verify the observations and explore possible conventional explanations. The team included experts in asteroid dynamics, comet physics, instrumental calibration, and data processing. Their first task was to rule out instrumental artifacts or data processing errors. Webb's sophisticated instruments occasionally produce spurious signals due to cosmic ray hits, electronic noise, or calibration drift. The team subjected Chen's observations to exhaustive analysis, comparing them with simultaneous observations of reference stars and known objects to verify the integrity of the data. Every test confirmed the signal was genuine. The object appeared consistently across multiple detector rays, showed the expected parallax shift indicating solar system location, and exhibited none of the characteristics typical of instrumental artifacts. The team expanded their analysis to include observations from other wavelengths and instruments, searching for any additional data that might shed light on the object's nature. Radio telescope archives revealed no detectable emission from the object's coordinates, eliminating the possibility of active radio transmission or natural synchrotron radiation. X-ray observatories had not targeted the region, but background survey data showed no unusual high-energy emission. Optical telescopes had, apparently overlooked the object due to its faint visible brightness. Focusing instead on the many background stars in the same field, the object existed primarily in the infrared realm, warm enough to emit thermal radiation detectable by Webb, but too cool or too small to produce significant optical emission. This characteristic suggested either a relatively small object with an unusually high temperature, or a larger object with selective infrared emission properties unlike any known material. Dr. Rodriguez's team then turned their attention to trajectory analysis. Using the growing collection of Webb observations spanning nearly 10 months, they refined the object's orbital parameters to unprecedented precision. The results confirmed Chen's initial assessment. The object followed a hyperbolic trajectory, originating from the direction of the heliopause, with course corrections that defied explanation through conventional celestial mechanics. The mathematical models revealed something even more disturbing. The object's trajectory would bring it to its closest approach to Earth in approximately 18 months, passing within the orbit of Mars at a distance of roughly 50 million kilometers. While not an immediate collision threat, this proximity would make the object easily detectable by ground-based telescopes and potentially visible to amateur astronomers with modest equipment. More significantly, the trajectory calculations showed that the object would reach its closest approach to the Sun about 6 months after its closest approach to Earth. The timing suggested that Earth, rather than the Sun, might be the object's primary target or destination. This possibility transformed the discovery from an astronomical curiosity into a potential planetary defense issue. The team's findings prompted the first of many secure briefings that would ultimately involve representatives from NASA, the European Space Agency, the Chinese National Space Administration, and various military and intelligence organizations from multiple countries. The briefings were classified at the highest levels, reflecting the potential implications of the discovery for global security and public stability. During these briefings, additional information emerged that had not been included in Chen's original report. Military surveillance systems, designed to track orbital debris and potential threats to satellite infrastructure, had detected unusual infrared signatures consistent with the Webb observations. These detections had initially been dismissed as calibration errors or cosmic ray events, but retrospective analysis confirmed their connection to the mysterious object. Ground-based infrared surveys, including those operated by asteroid detection programs, were tasked with attempting independent confirmation of the object's existence and trajectory. Within weeks, multiple facilities had successfully detected the object, confirming its position and movement according to the predictions derived from Webb data. The confirmatory observations brought both relief and deeper concern, relief that the discovery was genuine and not the result of some systematic error in Webb's instruments or data processing. Concern that the object was now confirmed to be real, unusual, and approaching the inner solar system with characteristics that challenged fundamental assumptions about natural objects. As the investigation expanded to include more facilities and researchers, maintaining secrecy became increasingly difficult. The scientific community operates on principles of open communication and peer review, making it virtually impossible to suppress significant discoveries indefinitely. However, the potential implications of premature public disclosure ranging from mass panic to interference with scientific investigation provided strong motivation for continued discretion. A decision was made to establish a classified consortium of researchers and institutions tasked with comprehensive study of the object while maintaining operational security. The consortium, ultimately involving over 50 researchers from a dozen countries, would be tasked with determining the object's nature, origin, composition, and potential threat level before any public announcement. This consortium model, while unprecedented in astronomical research, provided the framework for the most intensive investigation of a single object in the history of space science. Every available instrument capable of detecting or characterizing the object would be brought to bear on the mystery, while elaborate security measures ensured that information remained restricted to authorized personnel. The consortium's first major decision involved nomenclature. The object required an official designation for use in secure communications and research documents. Traditional asteroid and comet naming conventions seemed inadequate for something that might represent humanity's first contact with artificial extraterrestrial technology. After considerable debate, the object was designated Anomalous Object 2024 Alpha, or A0204A for short. The designation reflected both the year of discovery and the genuinely anomalous nature of the object's characteristics. It would be months before researchers would learn whether this designation would ultimately require revision to reflect an even more extraordinary truth about the object's nature and origin. Spectroscopic mysteries. As the consortium expanded its observational campaign, the focus shifted from basic detection and trajectory analysis to detailed spectroscopic investigation of the object's position and physical properties. Webb's advanced spectrographic capabilities, originally designed to analyze the atmospheres of distant exoplanets and the chemical evolution of early galaxies, proved ideally suited for dissecting the infrared emission from A0204A. Dr. Elena Vasquez, a specialist in astronomical spectroscopy from the European Southern Observatory, led the spectroscopic analysis effort. Her team began by obtaining high-resolution infrared spectra across Webb's full wavelength range, from 0.6 to 28.5 micrometers. The resulting data revealed emission spectrum unlike anything in existing databases of natural materials. Traditional spectroscopy relies on identifying characteristic absorption or emission lines that correspond to specific atoms, molecules, or crystalline structures. The spectra of asteroids typically show features related to silicate minerals, iron-rich compounds, or organic materials formed during the early solar system. Comets display emission lines from water vapor, carbon dioxide, and various organic compounds as they sublimate in response to solar heating. A0204A's spectrum showed none of these familiar features. Instead, the infrared emission displayed a complex pattern of broad emission bands and sharp spectral lines that defied identification using conventional spectral databases. Some features appeared consistent with metallic compounds, but in combinations and proportions that do not occur naturally in known solar system materials. Even more puzzling were spectral features that seemed to change over time as the object continued its approach toward the inner solar system. Spectral lines that appeared strong in early observations diminished or disappeared entirely in later spectra, while new features emerged that had not been present initially. This spectral evolution suggested ongoing chemical or physical processes within the object, processes that seemed to be triggered by changing environmental conditions. As it moved through different regions of the solar system, the team attempted to match the mysterious spectral features with laboratory databases of synthetic materials, industrial compounds, and exotic substances created under extreme conditions. This effort required accessing classified databases maintained by materials science laboratories, defense research institutions, and nuclear facilities. The search expanded to include hypothetical materials predicted by solid-state physics but never actually created or observed. After months of analysis, several spectral features showed tentative matches with exotic materials that exist only under extreme conditions or in theoretical models. Some emissions appeared consistent with materials that would only be stable at extremely high pressures or in the presence of intense magnetic fields. Others matched theoretical predictions for metamaterials with engineered optical properties that do not occur in nature. The implications were staggering. If the spectroscopic analysis was correct, A0204A was composed at least partially of materials that could not form through natural processes in the solar system environment. The presence of such materials would strongly suggest artificial origin, either through advanced manufacturing techniques or formation under conditions that do not exist naturally anywhere in the known solar system. Dr. Vasquez's team expanded their analysis to include polarimetry observations, which could reveal information about the object's surface structure and the organization of its constituent materials. Natural objects typically show polarization signatures related to scattering from irregular surfaces, dust particles, or crystalline structures aligned by magnetic fields or rotational forces. A0204A exhibited polarization characteristics suggesting highly organized surface structures. with geometric patterns not typical of natural erosion or accretion processes. The polarization varied systematically across the object's infrared emission spectrum, indicating that different wavelengths were being emitted from different surface regions or structures. These observations suggested that the object possessed complex surface topology with features arranged in non-random patterns. The systematic variation of polarization with wavelength indicated either multiple distinct surface materials arranged in geometric patterns, or surface structures designed to emit different wavelengths from specific locations. Such organization would be virtually impossible to achieve through natural processes, but would be consistent with engineered surface structures designed for specific optical or thermal properties. The implications supported the growing consensus within the consortium that A02O represented technology rather than a natural object. Thermal modeling based on the spectroscopic data revealed additional anomalies. The object's infrared emission spectrum indicated surface temperatures significantly higher than would be expected from solar heating alone at its current distance from the Sun. Moreover, the temperature distribution across the object appeared highly non-uniform, with some regions much hotter than others despite uniform solar illumination. The thermal characteristics suggested active internal heat generation through either radioactive decay, chemical reactions, or some form of energy conversion system. The non-uniform temperature distribution indicated either selective heating of specific regions or active thermal management systems designed to maintain different temperatures in different areas of the object. Natural objects can exhibit internal heating through radioactive decay, but the thermal signature of A02O did not match the expected patterns from natural radioactive materials. The heat generation appeared too intense and too spatially organized to result from randomly distributed radioactive elements. Chemical heating from reactions between different materials was another possibility, but the sustained nature of the heat generation over many months of observation suggested either an implausibly large reservoir of reactive materials or some form of controlled chemical process designed to maintain consistent energy output. The thermal management interpretation that the object was actively controlling its temperature distribution through engineered systems became increasingly compelling as more data accumulated. Such capability would represent technology far beyond current human engineering capabilities, but would explain the complex thermal signatures observed by Webb's instruments. As the spectroscopic investigation continued, additional instruments were brought online to expand the wavelength coverage and improve spectral resolution. Radio telescopes sensitive to millimeter and submillimeter wavelengths joined the observational campaign, searching for molecular emission lines that might reveal additional information about the object's composition. These observations detected faint emission lines that appeared consistent with complex organic molecules, but in forms and abundances that did not match any known natural processes. The molecular signatures suggested the presence of large, structured organic compounds possibly arranged in ordered arrays or crystalline forms. The detection of organized organic materials on what appeared to be an artificial object raised profound questions about the relationship between technology and biology in the object's origin. Were these materials evidence of biological processes, technological manufacturing using biological materials, or something entirely beyond current human understanding? Trajectory analysis. While spectroscopic analysis revealed A02O4A's exotic material composition, parallel efforts to understand its trajectory and orbital mechanics uncovered equally puzzling dynamics that challenged fundamental assumptions about how objects move through the solar system. Dr. James Park, a specialist in orbital mechanics from MIT, led an international team tasked with creating the most precise possible model of the object's path through space. Using observations spanning over a year from multiple space-based and ground-based facilities, Park's team had accumulated an unprecedented database of positional measurements for a single solar system object. The precision of these measurements, particularly those from Webb's exceptional astrometric capabilities, allowed trajectory calculations accurate to within a few kilometers across distances of billions of kilometers. The team's initial models confirmed earlier assessments that A02O followed a hyperbolic trajectory originating from the outer solar system. However, Detailed analysis revealed subtle but systematic deviations from the path predicted by simple gravitational models. These deviations were too large to be attributed to observational uncertainty, and too systematic to represent random perturbations from unmapped gravitational sources. The trajectory anomalies appeared as small but consistent accelerations that could not be explained by the gravitational influences of known planets, moons, or asteroid populations. The accelerations occurred in directions that seemed related to the object's orientation relative to the Sun, suggesting some form of directional force rather than purely gravitational effects. Natural objects can experience non-gravitational forces through several mechanisms. Comets often exhibit trajectory changes due to asymmetric outgassing as ice sublimates and creates thrust in specific directions. The Yarkovsky effect causes small accelerations when absorbed sunlight is re-radiated asymmetrically from rotating objects. Solar radiation pressure can influence the orbits of objects with high surface area to mass ratios. However, Auto-Autoforé's trajectory anomalies did not match the patterns expected from any of these natural non-gravitational forces. The accelerations were too large and too consistent to result from outgassing of volatile materials. The directions of the forces showed no correlation with the object's rotation or thermal emission patterns that would be expected for Yarkovsky effects. Solar radiation pressure could not account for accelerations of the observed magnitude without implying unrealistic physical properties for the object. Parkes' team explored increasingly exotic explanations for the trajectory anomalies. Could the object be experiencing forces from unmapped gravitational sources in the outer solar system? Theoretical models suggested that Planet 9, a hypothetical massive object in the distant outer solar system, might create subtle gravitational perturbations. However, the direction and timing of Auto-Autoforé's trajectory changes did not align with predictions for Planet 9's gravitational influence. Could electromagnetic forces play a role in the object's motion? Objects with significant electrical charge can experience forces when moving through the solar wind or interacting with planetary magnet icy fields. However, the magnitude of electromagnetic forces required to explain Auto-Autoforé's trajectory would require electrical charges far exceeding anything observed in natural solar system objects. The team gradually reached a conclusion that had profound implications for understanding the object's nature. The trajectory anomalies appeared most consistent with active propulsion-directed forces generated by the object itself rather than environmental influences acting upon it. The accelerations showed characteristics of controlled thrust applications designed to modify the object's path through space. This conclusion was supported by correlation analysis showing that trajectory changes often occurred when the object was oriented in specific directions relative to the Sun or other solar system bodies. The timing and magnitude of these changes suggested intentional course corrections rather than random environmental effects. If Auto-Autoforé possessed active propulsion capabilities, it represented technology far beyond current human spaceflight systems. The object had apparently been making course corrections over a period of years while traveling through the outer solar system, demonstrating sustained operational capability across vast distances and time periods. The propulsion analysis also revealed something even more significant about the object's ultimate destination. Detailed trajectory modeling showed that without the observed course corrections, Auto-Autoforé would have followed a path that bypassed the inner solar system entirely, passing through the outer edges of the asteroid belt before returning to interstellar space. The course corrections had systematically altered the object's trajectory to ensure a close approach toward H, rather than representing a random visitor from interstellar space. Auto-Autoforé appeared to be deliberately targeting Earth's vicinity. The precision of the course corrections required to achieve Earth approach from the object's original trajectory suggested sophisticated navigation capabilities and detailed knowledge of solar system structure. This finding transformed the consortium's assessment of the object from an interesting anomaly to a potential first contact scenario. If Auto-Autoforé was indeed an artificial object under intelligent control, its apparent targeting of Earth suggested intentional rather than accidental encounter with human civilization. The trajectory analysis also provided constraints on the object's propulsion system. Characteristics: the observed accelerations could be achieved through several different propulsion technologies, each with different implications for the object's origin and capabilities. Chemical propulsion, similar to conventional rocket systems, could theoretically produce the observed accelerations. However, the sustained nature of the course corrections over years of operation would require enormous fuel reserves, making the object implausibly massive unless it possessed extremely efficient propulsion technology. Electric propulsion systems, such as ion drives, could operate for extended periods with relatively modest fuel requirements. However, such systems typically produce much smaller accelerations than those observed from A02O24A. Achieving the observed performance would require electric propulsion technology for more advanced current human systems. Exotic propulsion concepts, such as solar cells or electromagnetic drives, might explain some aspects of the object's motion. However, none of these technologies could fully account for the observed trajectory characteristics without invoking performance levels that exceed theoretical limits based on known physics. The propulsion analysis ultimately suggested that A02O24A employed propulsion technology that was either far more advanced than current human capabilities or based on physical principles not yet understood by terrestrial science. Either possibility had profound implications for humanity's first encounter with the object as it approached the inner solar system. The growing consensus by early 2025, over 18 months after Dr. Chen's initial discovery, the consortium investigating A02O24A had accumulated an overwhelming body of evidence pointing toward a single, extraordinary conclusion. The object exhibited characteristics that could not be explained through any known natural processes or conventional astronomical phenomena. Its exotic material composition, active thermal management, controlled trajectory modifications, and apparent targeting of Earth strongly suggested artificial origin under intelligent control. This consensus emerged gradually through months of rigorous analysis, peer review, and attempts to find conventional explanations for the object's anomalous properties. Every effort to explain A02O24A as a natural object, whether an unusual asteroid, exotic comet, or previously unknown class of solar system body, had failed to account for the full range of observed characteristics. The implications of this conclusion were so profound that consortium leadership initiated a comprehensive review process to ensure absolute certainty before proceeding with any policy recommendations. Independent teams were tasked with reanalyzing all observational data, while theoretical working groups explored every conceivable natural explanation for the object's properties. Dr. Margaret Stevens, a senior researcher at the SETI Institute and consortium member specializing in technosignature analysis, led the effort to establish definitive criteria for distinguishing between natural and artificial objects. Her team developed a comprehensive framework for evaluating the evidence, drawing on decades of research into potential indicators of extraterrestrial technology. The SETI methodology relied on multiple independent lines of evidence, each providing probabilistic rather than definitive proof of artificial origin. No single observation could conclusively demonstrate that A02O24A was technological, but the cumulative evidence from multiple independent measurements created a statistical case that became increasingly compelling as more data accumulated. Stevens' analysis assigned probability scores to each major observational finding based on how likely those findings would be for natural versus artificial objects, the exotic spectral signatures, controlled thermal emission, trajectory anomalies, and apparent course corrections. Each received probability assessments based on comparison with known natural processes and theoretical artificial capabilities. When combined using standard statistical methods for multiple independent observations, the overall probability assessment strongly favored artificial origin. The mathematical analysis suggested less than a 1% chance that all observed characteristics could result from natural processes acting on a conventional solar system object. This statistical conclusion provided the scientific foundation for the consortium's preliminary assessment that A02O24A represented humanity's first confirmed detection of extraterrestrial technology. However, reaching this conclusion also triggered complex policy discussions about appropriate responses and Public disclosure protocols. The institutional response to the consortium's preliminary findings involved the highest levels of government and international organizations. NASA Administrator Dr. Patricia Williams convened an emergency meeting of the agency's senior leadership to discuss the implications and develop response protocols. Similar high-level meetings occurred at space agencies around the world as news of the discovery spread through classified channels. The initial institutional response focused on three primary concerns: verification of the findings, assessment of potential threats or opportunities, and management of public disclosure. Each concern required coordination between multiple agencies and organizations with different areas of expertise and responsibility. Verification efforts expanded the observational campaign to include every available instrument capable of detecting or characterizing A0204A. Military surveillance systems were tasked with continuous monitoring of the object's position and behavior. Deep space communication systems began listening for any radio or other electromagnetic emissions that might indicate attempts at communication. Threat assessment became a complex exercise involving intelligence agencies, military organizations, and academic institutions specializing in strategic analysis. The object's apparent targeting of Earth raised obvious security concerns. While its advanced propulsion and materials technology suggested capabilities that could pose significant risks to human civilization. However, threat assessment was complicated by the lack of any hostile indicators in the object's behavior. A0204A had made no attempts at communication, shown no aggressive maneuvering, and exhibited no emissions or activities that suggested preparation for hostile action. The object appeared to be simply approaching Earth while maintaining its complex thermal and spectral characteristics. Public disclosure management became perhaps the most challenging aspect of the institutional response. The potential for mass panic, economic disruption, or interference with scientific investigation argued for continued secrecy until more definitive information could be obtained. However, the growing number of people involved in the investigation made long-term secrecy increasingly difficult to maintain. The decision was made to establish a graduated disclosure protocol that would allow controlled release of information as the situation developed. Initial phases would involve briefing selected political leaders, scientific organizations, and media representatives under strict confidentiality agreements. Later phases could include public announcements calibrated to minimize panic while preparing society for potential contact with extraterrestrial intelligence. This graduated approach required unprecedented coordination between normally independent organizations, space agencies, intelligence services, military commands, and academic institutions had to develop shared protocols for information management while maintaining their distinct roles and responsibilities. The complexity of institutional coordination led to the establishment of a dedicated task force reporting directly to heads of government in major spacefaring nations, the A0204A Task Force, as it became known in classified communications, brought together representatives from space agencies, defense organizations, intelligence services, and academic institutions under a unified command structure. The task force's primary responsibilities included coordinating international observational efforts, developing response scenarios for various potential outcomes, and managing information security while preparations continued for eventual public disclosure. This coordination required balancing the competing interests of transparency, security, and scientific investigation. As the object continued its approach toward the inner solar system, the task force faced increasing pressure to develop concrete response plans. A0204A would reach its closest approach to Earth within months, making it visible to amateur astronomers and potentially detectable by media organizations with access to moderate-sized telescopes. The window for controlled disclosure was rapidly closing, while the need for definitive answers about the object's nature and intentions became increasingly urgent. The consortium's scientific investigation had provided compelling evidence for artificial origin, but many questions about the object's capabilities, intentions, and response to human contact remained unanswered. Deep space communication. As A0204A continued its approach toward Earth, the International Task Force faced a critical decision about attempting communication with what appeared to be humanity's first confirmed extraterrestrial visitor, the object's artificial characteristics and apparent intentional targeting of Earth suggested intelligence behind its mission, raising both hopes for peaceful contact and concerns about potential risks of active engagement. Dr. Alexander Petrov, director of the Arecibo Observatory's successor facility and a leading expert in interstellar communication protocols, was appointed to lead the communication effort. His team faced the unprecedented challenge of developing first contact protocols for an object that might possess technology far beyond human capabilities. The communication team's first challenge involved determining whether A0204A was actively monitoring for signals from Earth. The object had shown no detectable radio emissions during months of observation by sensitive radio telescopes around the world. This silence could indicate either lack of communication technology, deliberate maintenance of communication discipline, or use of communication methods beyond current human detection capabilities. Traditional SETI protocols assume that extraterrestrial intelligence would either actively transmit signals toward Earth or respond to signals transmitted from Earth. A0204A's behavior fit neither pattern, suggesting either different communication preferences or a monitoring approach that avoided revealing capabilities until direct contact became necessary. The team developed a graduated communication protocol that began with passive observation using the most sensitive radio telescopes available, the Very Large Array, Atacama Large Millimeter Array, and other major radio facilities were tasked with continuous monitoring of A0204A across the full electromagnetic spectrum, searching for any signals that might indicate communication attempts or technological emissions. These passive monitoring efforts detected no artificial signals from the object. However, they did reveal subtle but systematic variations in the object's natural infrared emissions that appeared to follow low mathematical patterns. The variations were too regular to represent random thermal fluctuations and too complex to result from simple physical processes. Analysis of these emission patterns revealed sequences that appeared to follow mathematical progressions, geometric relationships, and even patterns reminiscent of prime number sequences. While not definitively artificial, the patterns suggested possible intentional encoding of information in the object's thermal emissions. This finding prompted the decision to begin active communication attempts. The team transmitted a series of mathematical and scientific concepts using precisely controlled radio signals directed toward A0204A's predicted position. The messages began with basic mathematical relationships, progressed through fundamental physical constants, and included information about Earth's location, human civilization, and peaceful intentions. The transmission protocol followed established SETI guidelines for interstellar communication, using frequencies and signal formats designed to be easily detectable by any technologically advanced civilization. However, the team also experimented with alternative communication methods, including modulated laser transmissions and precisely timed sequences of radio bursts. Initial communication attempts produced no detectable response from A0204A. The object continued its approach trajectory without deviation, maintained its complex thermal emission patterns, and showed no changes in behavior that might indicate reception or acknowledgement of human signals. However, detailed analysis of the object's behavior after communication attempts revealed subtle but systematic changes in its emission patterns. The mathematical sequences embedded in the thermal emissions became more complex and appeared to incorporate elements that matched the mathematical concepts transmitted from Earth. These changes were extremely subtle and required sophisticated signal processing techniques to detect. The modifications appeared in the form of slight variations in the timing and intensity of thermal emission cycles, creating patterns that could be interpreted as responses to the transmitted mathematical concepts. The apparent responsiveness suggested that A0204A was indeed monitoring human transmissions and incorporating received information into its own emission patterns. However, the subtlety of the responses indicated either deliberate restraint in revealing communication capabilities or use of communication methods that prioritize subtlety over obvious signal exchange. Dr. Petrov's team expanded their communication efforts to include more complex concepts and direct questions about the object's origin, purpose, and intentions. They transmitted information about human civilization, Earth's biosphere, and humanity's interest in peaceful contact with extraterrestrial intelligence. The response patterns became increasingly sophisticated, suggesting not only reception of transmitted information but also systematic analysis and integration of human concepts. The emission patterns began to exhibit characteristics that appeared to reference Earth's astronomical position, solar system structure, and even basic elements of human mathematics and physics. These developments provided compelling evidence that A0204A possessed not only artificial intelligence but also sophisticated analysis capabilities that allowed rapid understanding of human communication attempts. The object appeared to be learning about human civilization through the transmitted information while responding in ways that demonstrated comprehension without revealing detailed capabilities. However, the communication remained essentially one-sided. While A0204A appeared to be responding to human transmissions, it provided no clear answers to direct questions about its origin, purpose, or intentions. The response patterns conveyed acknowledgement and understanding but avoided revealing information that might illuminate the object's mission or capabilities. This communication pattern suggested a deliberate strategy of minimal engagement that demonstrated intelligence and peaceful intentions while maintaining operational security about the object's true nature and purpose. Such a strategy would be consistent with cautious first contact protocols that prioritized assessment and gradual engagement over immediate full disclosure. The communication team also noted that A0204A's responses became more sophisticated as the object approached closer to Earth. The emission patterns grew more complex and appeared to incorporate increasingly detailed knowledge about human civilization, suggesting ongoing analysis of human transmissions and possibly observation of Earth's electromagnetic emissions. Radio telescopes monitoring Earth's radio leakage. The unintentional electromagnetic emissions from television, radio, radar, and communication systems detected corresponding patterns in A0204A's emissions that suggested the object was analyzing and cataloging human technological signatures. This comprehensive monitoring capability implied intelligence-gathering activities that went far beyond simple acknowledgement of intentional communication attempts. A0204A appeared to be conducting systematic analysis of human civilization, technology, and communication patterns as it approached Earth. The implications of such comprehensive surveillance capabilities raised new questions about the object's intentions and the extent of its technological sophistication. An intelligence capable of real-time analysis of human civilization's electromagnetic signature would possess capabilities that could support either peaceful contact or more concerning assessment. Activities. Physical characteristics. As A0204A approached within the telescopic range of ground-based observatories, the consortium gained access to new observational techniques that provided the first direct measurements of the object's physical dimensions, shape, and surface characteristics. These observations would prove crucial for understanding the scale and nature of what was approaching Earth. Dr. Lisa Wang, an expert in high-resolution imaging at the Keck Observatory, led efforts to obtain direct images of A0204A using advanced adaptive optics systems. The challenge was significant even at its closest approach. The object would subtend an angular size smaller than most asteroids observed from Earth, requiring the most sophisticated imaging techniques available to resolve any surface details. Initial imaging attempts using conventional techniques produced only point source detections, confirming the object's presence but revealing no details about its shape or structure. However, advanced image processing techniques developed for exoplanet detection and asteroid characterization began to extract meaningful information from the accumulated observations. Speckle interferometry, a technique that combines multiple short-exposure images to overcome atmospheric turbulence, provided the first hints of the object's non-spherical shape. The technique revealed subtle asymmetries in the point spread function that suggested an elongated or irregular object rather than the circular profile expected from a spherical body. Luck imaging, which selects only the sharpest frames from long sequences of images taken during optimal atmospheric conditions, confirmed the speckle interferometry results and provided additional details about the object's orientation and rotation state. The combined techniques suggested an object with a length-to-width ratio of approximately 3:1, rotating with a period of several hours. However, the most detailed physical characterization came from radar observations conducted by the Arecibo Observatory's replacement facility and the Goldstone Deep Space Communications Complex. Radar techniques can provide extremely precise measurements of object size, shape, rotation, and surface properties, even for targets too small to resolve optically. The radar observations revealed an object with overall dimensions of approximately 400 meters in length and 130 meters in maximum width, roughly the size of a large building or small mountain. However, the radar signature showed characteristics unlike any natural asteroid or comet previously studied. Natural objects typically show radar returns dominated by surface roughness and irregular topography created by impact cratering, thermal cycling, and other erosion processes. A0204A's radar signature suggested a surface with geometric regularities and smooth sections. That would be extremely unlikely to occur naturally. The radar data revealed flat surfaces, regular geometric shapes, and what appeared to be organized structural elements arranged in systematic patterns. These characteristics strongly supported artificial origin while providing the first detailed information about the object's construction and design. Three-dimensional modeling based on the radar observations produced images of an elongated object with a complex but organized surface structure. The object appeared to consist of multiple geometric sections connected by what might be structural elements or functional components. The overall design suggested neither random accretion of natural materials nor simple erosion of a larger body. Instead, the object showed characteristics of deliberate construction with functional elements arranged according to engineering rather than natural principles. Surface temperature mapping using high-resolution infrared observations revealed thermal characteristics that correlated with the geometric structures identified by radar. Different structural elements maintain different temperatures, suggesting either selective heating of specific components or active thermal management systems designed to optimize the performance of different functional elements. The temperature variations were too systematic and too stable to result from passive thermal processes. Natural objects show temperature variations related to solar illumination patterns, thermal inertia of different materials, or internal heat sources, but not the precisely controlled thermal patterns observed on A0204A. Photometric analysis of reflected sunlight provided additional information about the object's surface properties and composition, unlike natural objects, which typically show variations in reflectivity related to mineral composition or surface weathering. A0204A displayed highly uniform reflective properties across its entire surface. The uniform reflectivity suggested either a surface coating or treatment designed to provide consistent optical properties, or construction from materials with inherently uniform reflective characteristics. Natural processes do not produce such uniform surface properties across objects of this size. Polarimetry observations revealed additional evidence of surface organization. The polarization of reflected sunlight showed systematic variations that correlated with the structural elements identified by radar, suggesting organized surface features with controlled optical properties. These observations provided compelling evidence that A0204A possessed surface structures designed for specific optical, thermal, or functional purposes rather than the random arrangements typical of natural objects. The systematic organization of surface features suggested engineering design principles applied at the scale of the entire object. The physical characterization also revealed rotation characteristics that provided insights into the object's stability and control systems. Natural objects typically show rotation rates determined by their formation history and subsequent collision experiences. A0204A's rotation appeared to be precisely controlled, with stability that suggested active attitude control rather than natural rotation dynamics. The object maintained precise three-axis stability despite the gravitational perturbations expected during its passage through the solar system, Such stability would require either extremely precise mass distribution or active control systems, capable of making continuous corrections to maintain desired orientation. The rotation period and axis orientation appeared optimized to maintain specific thermal and communication conditions relative to the Sun and Earth. This optimization suggested intentional attitude control designed to support the object's mission requirements rather than random orientation resulting from natural dynamics. Mass estimation based on trajectory analysis and the object's response to gravitational perturbations revealed a density significantly higher than typical natural objects of similar size. The high density suggested either construction from unusually dense materials or compact internal structure with minimal void space. The combination of large size, high density, organized surface structure, and controlled dynamics painted a picture of A0202-4A as a sophisticated technological object with capabilities far exceeding anything in human experience. The physical characteristics provided strong confirmation of the spectroscopic and behavioral evidence for artificial origin while revealing the impressive scale and apparent sophistication of the approaching object. The approach, as A0202-4A continued its steady approach toward Earth throughout late 2025, maintaining secrecy about the discovery became increasingly difficult. The object's growing brightness made it detectable by amateur astronomers with modest equipment, while its unusual characteristics attracted attention from independent researchers around the world. Dr. Amanda Foster, a science journalist with connections throughout the astronomical community, began to notice unusual patterns in telescope scheduling and research activities at major observatories. Normally, public facilities were conducting classified observations, while prominent researchers were avoiding conferences and limiting their usual open communication about ongoing projects. Foster's investigation revealed coordination between normally independent institutions that suggested a significant discovery requiring international cooperation and security measures. Her sources within the astronomical community provided fragmentary information about unusual objects and coordinated observation campaigns, but none were willing to provide details about the nature of the discovery. The first public hint of A0202-4A's existence came from an unexpected source. Dr. Robert Chen, an amateur astronomer and retired physics professor in California, detected an unusual moving object during routine observations with his privately owned 16-inch telescope. His measurements showed an object with infrared emission characteristics that did not match any known solar system objects. Chen published his observations on amateur astronomy forums, describing the object as a possible new comet or unusual asteroid with atypical thermal properties. His post attracted attention from other amateur observers, several of whom confirmed the detection and began conducting their own observations. Within weeks, a small community of amateur astronomers had independently discovered A0202-4A and begun coordinating observations to track its movement and characterize its properties. Their measurements, while less precise than professional observations, confirmed the object's unusual characteristics and consistent with the classified findings of the international consortium. The amateur observations created a dilemma for the task force managing the official investigation. The object's existence was no longer secret, but the amateur observers lacked the sophisticated instruments necessary to detect the most anomalous characteristics that had led to the conclusion of artificial origin. Dr. Chen and his colleagues interpreted their observations as evidence of a previously unknown class of solar system object, perhaps a fragment from the outer solar system with unusual composition or internal structure. Their speculation focused on natural explanations for the object's properties, unaware of the more exotic possibilities revealed by professional observations. The task force faced a decision about whether to intervene in the amateur observations, provide guidance that might steer interpretation toward more conventional conclusions, or allow independent analysis to proceed without official input. Each option carried risks for maintaining operational security while ensuring public safety. The decision was made to monitor amateur observations closely while preparing for eventual public disclosure, as the object's approach made concealment impossible. Plans were developed for coordinated announcement of the discovery through official channels before amateur observations could lead to speculation that might cause public alarm. However, events moved faster than planned. Dr. Foster's journalistic investigation had identified several sources willing to provide background information about unusual activities at major observatories and space agencies. Her article, published in a major science magazine, revealed the existence of a coordinated international investigation of an unusual object approaching Earth. Foster's article did not reveal the classified conclusions about A0204A's artificial nature, but it described institutional behavior consistent with a discovery of extraordinary significance. The article noted the involvement of military and intelligence organizations alongside scientific institutions, suggesting implications beyond routine astronomical research. The publication of Foster's article triggered immediate responses from space agencies around the world. NASA issued a carefully worded statement acknowledging the discovery of an unusual object under investigation, while emphasizing that preliminary analysis suggested no immediate threat to Earth. The statement described A0204A as an object of unknown origin with characteristics requiring detailed investigation to determine its nature and composition. The language was carefully chosen to acknowledge the discovery while avoiding speculation about artificial origin or extraterrestrial intelligence. However, the combination of Foster's article and the official acknowledgement created intense public and media interest in the object. Speculation ranged from conventional explanations involving unusual asteroids or comets to more exotic possibilities including artificial origin. The space agency's cautious language and obvious reluctance to provide detailed information fueled conspiracy theories and speculation about cover-ups or hidden knowledge. About the object's true nature, social media platforms filled with discussions ranging from scientific analysis to wild speculation about alien visitation and government secrecy. The growing public interest created pressure for more detailed disclosure while simultaneously making complete revelation of the object's apparent artificial nature more politically and socially challenging. The task force found itself caught between demands for transparency and concerns about public reaction to confirmation of extraterrestrial intelligence. Dr. Williams convened an emergency meeting of the task force to develop response strategies for managing public disclosure in an environment of intense speculation and media attention. The meeting brought together representatives from space agencies, intelligence organizations, and communication specialists to address the challenges of first contact disclosure in a democratic society. The consensus emerged that controlled disclosure was preferable to allowing speculation to spiral out of control. A gradual revelation strategy was developed that would provide increasing levels of detail about A0204A's characteristics while preparing the public for the ultimate conclusion about its artificial nature. The first phase of disclosure involved releasing detailed scientific observations about the object's trajectory, physical characteristics, and composition while avoiding explicit conclusions about artificial origin. This information would allow the scientific community and informed public to draw their own conclusions while demonstrating the thoroughness of the official investigation. Subsequent phases would include discussion of the object's anomalous characteristics, the difficulty of explaining these characteristics through natural processes, and ultimately the growing consensus that A0204A represented technology of non-terrestrial origin. This disclosure strategy required careful coordination between multiple agencies and organizations to ensure consistent messaging while avoiding premature revelation that might cause panic or interfere with ongoing investigation and potential contact efforts. Diplomatic preparations ***, the approaching confirmation of humanity's first contact with extraterrestrial intelligence created unprecedented challenges for international cooperation and diplomatic preparation. The discovery of A0204A's artificial nature required coordinated response from the global community, yet occurred within existing frameworks of national sovereignty, security concerns, and competitive interests that complicated unified action. Ambassador Sarah Martinez, formerly the U.S. representative to the United Nations Office for Outer Space Affairs, was appointed as Special Coordinator for International Diplomatic Responses to the A0204A situation. Her mandate involved developing protocols for first contact that respected both national security interests, and the global significance of extraterrestrial contact. Martinez's first challenge involved expanding the classified consortium investigating AO2024A to include diplomatic and policy specialists from major world governments. This expansion required balancing the need for comprehensive international representation with security requirements that limited access to the most sensitive information about the objects, capabilities, and potential intentions. The diplomatic coordination effort ultimately involved representatives from the United States, European Union, China, Russia, India, Japan, and other major spacefaring nations, along with observers from the United Nations and various international organizations. This group, operating under extreme security constraints, began developing frameworks for coordinated response to first contact. The diplomatic discussions revealed fundamental disagreements about appropriate responses to extraterrestrial contact. Some nations advocated for open, transparent engagement that would demonstrate humanity's peaceful intentions and desire for beneficial contact. Others argued for cautious, security-focused approaches that would protect national interests while avoiding potential threats to human civilization. These philosophical differences reflected deeper disagreements about the nature of sovereignty, security, and representation in the context of species-level contact with extraterrestrial intelligence. Traditional diplomatic frameworks assumed interaction between human political entities, not contact between humanity as a species and non-terrestrial intelligence. The question of who could legitimately speak for humanity in first contact situations had no established answer in international law or diplomatic practice. Individual nations claimed authority based on their technological capabilities and space programs, while international organizations argued for representation based on global mandates and inclusive membership. Martinez's team worked to develop compromise frameworks that would allow coordinated response while respecting the legitimate interests of all parties. These frameworks established principles for shared decision-making, information exchange, and coordinated communication with extraterrestrial intelligence while preserving national autonomy for internal policy decisions. The diplomatic preparations also address practical questions about physical contact protocols should AO2024A attempt landing or close approach to Earth. Which nation's territory would be appropriate for contact? What security measures would be necessary? How would access and information sharing be managed among the international community? These questions required developing entirely new categories of international law and diplomatic protocol. Existing frameworks for spacecraft recovery, territorial sovereignty, and international cooperation in space provided some precedent, but nothing approaching the complexity of managing first contact with extraterrestrial intelligence. The legal implications of first contact extended far beyond diplomatic protocol. Questions of property rights, technology transfer, environmental protection, and human safety required careful analysis by international legal experts working within the security constraints imposed by the classified nature of the investigation. Dr. Patricia Robinson, an international law specialist at Oxford University, led efforts to develop legal frameworks for first contact that would protect human interests while avoiding violations of Why rights that extraterrestrial intelligence might possess. Her work required pioneering entirely new areas of jurisprudence related to interspecies contact and non-terrestrial legal entities. The legal analysis addressed questions of extraterrestrial rights that had never before required practical consideration. Did intelligent non-terrestrial entities possess rights under international law? How would conflicts between human and extraterrestrial interests be resolved? What legal frameworks would govern potential technology transfer or territorial access? These abstract legal questions became increasingly practical as AO2024A continued its approach toward Earth. The object's apparent intelligence and sophisticated technology suggested contact with entities that might have legitimate interests requiring legal protection. Yet no existing framework addressed such possibilities. The diplomatic and legal preparations occurred alongside military planning for various contingency scenarios, while AO2024A had shown no hostile behavior. Its advanced technology and unknown intentions required preparation for various possible outcomes, ranging from peaceful contact to potential security threats. General Patricia Hayes, commander of the newly established Space Force operations, coordinated military planning with her counterparts from other major military organizations. Their planning addressed defensive preparations, communication security, and coordination with civilian authorities while avoiding actions that might be interpreted as hostile by approaching extraterrestrial intelligence. The military planning revealed the complete inadequacy of existing defensive capabilities against technology as advanced as that demonstrated by O2024A, the object's propulsion capabilities, material technology, and apparent intelligence suggest a technological superiority that would make any defensive measures largely symbolic rather than practically effective. This technological disparity reinforced arguments for diplomatic rather than military responses to first contact. Humanity's best interests appeared to lie in demonstrating peaceful intentions and seeking beneficial cooperation rather than preparing for conflict against vastly superior technology. However, military planners continued developing contingency responses for various scenarios while acknowledging the limitations of current human capabilities. These preparations focused on information security, protection of critical infrastructure, and coordination with civilian authorities rather than direct defensive measures against extraterrestrial technology. The international coordination effort also addressed public communication strategies for managing disclosure of first contact. Different nations had different approaches to public information management, creating challenges for coordinated messaging about developments in the O2024A investigation. Communication specialists from participating nations worked to develop consistent approaches to public disclosure that would avoid conflicting messages while respecting different cultural and political contexts. This effort required balancing transparency demands with security requirements across multiple different political systems and media environments. The communication strategy ultimately adopted a science-focused approach that emphasized the extraordinary nature of the discovery while avoiding speculation about intentions or implications. Until more definitive information became available, this approach aimed to prepare the public gradually for the reality of extraterrestrial contact while maintaining calm and avoiding panic. Scientific breakthroughs and technological implications ***. As the international consortium continued its intensive study of O2024A, the accumulating data began revealing technological principles and capabilities that challenged fundamental assumptions about physics, engineering, and the possibilities for advanced civilizations. These discoveries had implications extending far beyond the immediate first contact situation, potentially revolutionizing human understanding of science and technology. Dr. Michael Zhang, a theoretical physicist from CERN specializing in exotic matter and advanced propulsion concepts, led efforts to understand the physical principles underlying O2024A's observed capabilities. His analysis focused on the object's apparent propulsion system, which had demonstrated performance characteristics that exceeded known limitations of conventional physics. The trajectory analysis had revealed accelerations and course corrections that could not be explained by chemical, electric, or nuclear propulsion systems operating within understood physical constraints. The object appeared to be violating conservation of momentum unless it was interacting with spacetime or quantum fields in ways not yet understood by human science. Zhang's team explored various theoretical mechanisms that might explain O2024A's propulsion capabilities, all Cuvier-derived concepts, based on controlled distortion of spacetime geometry, could theoretically achieve apparent faster-than-light motion without violating relativity. However, such drives would require exotic matter with negative energy density that had never been observed or created in any laboratory. The spectroscopic analysis of O2024A had indeed revealed material characteristics that might be consistent with exotic matter, but confirming such exotic properties would require direct analysis that remained impossible at the object's current distance. The possibility that humanity was observing its first example of exotic matter technology had profound implications for physics and engineering. Alternative explanations for the propulsion anomalies included interaction with quantum vacuum fluctuations, manipulation of zero-point energy fields, or utilization of extra-dimensional physics beyond the standard model of particle physics. Each possibility would represent revolutionary advances in fundamental physics with applications extending far beyond spacecraft propulsion. Dr. Zhang's analysis also addressed the object's apparent energy generation capabilities. The sustained thermal emission over months of observation implied either enormous energy storage or highly efficient energy generation systems operating on principles unknown to current human technology. Fusion power, while highly efficient by current standards, could not easily account for the observed energy output without implying fuel storage requirements that would conflict with the object's apparent and mass and size constraints. More exotic energy generation mechanisms, such as matter-time matter annihilation or vacuum energy extraction, might explain the observed performance but would represent technological capabilities far beyond current human achievement. The materials analysis led by Dr. Vasquez revealed additional implications for advanced technology. The spectroscopic signatures suggesting engineered metamaterials with controlled electromagnetic properties could revolutionize communications, energy management, and structural design if the underlying principles could be understood and replicated. Some spectral features appeared consistent with materials that would only be stable under extreme conditions, suggesting either manufacturing processes involving conditions not achievable with current human technology, or fundamental advances in materials science that allowed creation of previously impossible material structures. The thermal management capabilities demonstrated by O2O implied sophisticated control over heat generation, distribution, and radiation that could transform terrestrial technology applications. Precise thermal control at the scale of the entire object suggested engineering principles that could revolutionize everything from electronics cooling to industrial process control. Dr. Lisa Chen, a computer scientist and artificial intelligence researcher from MIT, analyzed the apparent information processing capabilities demonstrated by O2O responses to human communication and attempts, the object's ability to rapidly analyze and respond to complex mathematical and scientific concepts suggested computational capabilities that exceeded current human achievements by orders of magnitude. The real-time analysis of human civilization's electromagnetic emissions implied information processing systems capable of handling enormous data streams while extracting meaningful patterns and insights. Such capabilities would require either vastly parallel processing architectures or fundamental advances in computational efficiency beyond anything achieved by human technology. The apparent learning capability demonstrated as O2O responses became more sophisticated over time suggested artificial intelligence systems with adaptability and creativity that exceeded current machine learning capabilities. The object appeared to be developing increasingly sophisticated models of human civilization and communication based on observed data. These computational capabilities had implications extending far beyond their immediate application to first contact. Understanding the principles underlying such advanced information processing could revolutionize human technology in areas ranging from scientific research to economic modeling to creative endeavors. The integration of all these advanced capabilities, exotic propulsion, sophisticated materials, advanced energy systems, and superior information processing in a single technological system represented an existence. Proof that such integrated advanced technology was physically possible. This demonstration potentially accelerated human technological development by confirming the feasibility of capabilities that might otherwise require centuries of theoretical development. However, the technological implications also raise concerns about the potential impact of contact with such advanced capabilities. Human civilization had developed existing technological, economic, and social structures based on current physical and engineering limitations. Contact with vastly superior technology could disrupt these structures in ways that might be beneficial or harmful, depending on how the transition was managed. The consortium began developing assessment frameworks for managing technological contact that would maximize benefits while minimizing disruption to human civilization. These frameworks address questions of technology transfer, intellectual property, economic impact, and social adaptation that would become crucial if contact led to sharing of advanced technological knowledge. The assessment revealed that even limited exposure to the technological principles demonstrated by O2024A could trigger revolutionary changes in human capabilities that would reshape civilization. Fundamentally, managing such changes would require unprecedented coordination between technological, economic, and social institutions to ensure beneficial outcomes for humanity as a whole. The technological analysis also provided insights into the probable capabilities and limitations of the civilization that had created O2024A. The integrated advanced technologies suggested a civilization with mastery of physical principles and engineering capabilities far exceeding human achievement, but operating within the same universe of physical law that constrained human technology development. This analysis suggested that contact with O2024A's creators would involve interaction with intelligences that were technologically superior but not omnipotent, advanced but not magical, and operating according to discoverable principles rather than incomprehensible capabilities. Such contact might be manageable and beneficial if approached with appropriate caution and preparation. First contact ***, the approaching reality of confirmed extraterrestrial contact created unprecedented challenges for understanding and managing the psychological and social impacts on human civilization. Dr. Jennifer Adams, a psychologist specializing in stress response and social dynamics, led efforts to assess and prepare for the mental health and social consequences of first contact. Disclosure: Adams' analysis drew on research from disaster psychology, social change dynamics, and historical studies of cultural contact to develop models for predicting human responses to extraterrestrial contact. However, the unprecedented nature of species-level first contact meant that most existing research provided only partial guidance for understanding the potential impacts. The psychological impact of confirming extraterrestrial intelligence would challenge fundamental assumptions about humanity's place in the universe that form core elements of individual and cultural identity, religious beliefs, philosophical frameworks, and scientific worldviews would all require reassessment in light of confirmed contact with non-terrestrial intelligence. Adams' team conducted confidential surveys of individuals with access to classified information about O2024A to assess psychological responses to knowledge of extraterrestrial contact. These surveys revealed wide variation in individual responses, ranging from excitement and wonder to anxiety and existential distress. Common psychological responses included initial disbelief followed by gradual acceptance, increased interest in fundamental questions about existence and meaning, and concerns about the implications of contact for human autonomy and future development. Many individuals reported significant changes in personal priorities and life perspectives after learning about the discovery. The survey results suggested that most psychologically healthy individuals could adapt to knowledge of extraterrestrial contact without severe distress, but that the adjustment process required time and support. Individuals with existing mental health challenges showed increased vulnerability to anxiety and depression related to the implications of contact. These findings informed development of public mental health preparedness programs designed to support psychological adaptation to first contact disclosure. The programs included public education about expected psychological responses, resources for individuals experiencing contact-related distress, and training for mental health professionals in contact-related counseling techniques. The social implications of first contact extended beyond individual psychological responses to include potential changes in social structures, institutions, and cultural practices. Dr. Robert Thompson, a sociologist specializing in social change and technological impact, analyzed the potential societal consequences of contact with advanced extraterrestrial intelligence. Thomson's analysis suggested that contact with technologically superior intelligence would challenge existing power structures, economic systems, and social hierarchies in ways that could either strengthen or destabilize human civilization. Depending on how the transition was managed, religious institutions would face particular challenges in interpreting extraterrestrial contact within existing theological frameworks. Some religious traditions might readily accommodate contact with non-terrestrial intelligence, while others could experience theological crises requiring fundamental revision of doctrinal beliefs about humanity's relationship to the divine. The economic implications of potential technology transfer from advanced extraterrestrial intelligence could disrupt existing industries, employment patterns, and economic relationships in ways that might benefit humanity overall while creating severe hardship for individuals and communities dependent on technologies that might become obsolete. Political systems would face challenges in representing human interests in contact with intelligences that might not recognize existing national boundaries, political authorities, or legal frameworks. The legitimacy of existing political institutions could be challenged if extraterrestrial contact required new forms of governance adapted to species-level decision-making. Educational institutions would need to revise curricula across multiple disciplines to incorporate new understanding of physics, technology, biology, and cosmology implied by confirmed extraterrestrial intelligence. This revision would require unprecedented coordination between educational systems worldwide to ensure consistent and accurate information dissemination. The media and entertainment industries would play crucial roles in shaping public understanding and emotional responses to extraterrestrial contact. Responsible reporting and cultural representation could support healthy adaptation to contact, while sensationalized or fearful portrayals could increase anxiety and social disruption. Adams and Thomson collaborated on developing social preparedness strategies designed to maximize the beneficial impacts of first contact while minimizing potential disruption and distress. These strategies emphasized gradual disclosure, comprehensive public education, and strengthening of social support systems to help individuals and communities adapt to the new reality. The preparedness strategies also addressed potential negative reactions to first contact, including increased xenophobia, conspiracy theories, and social unrest. Plans were developed for managing these challenges through effective communication, community engagement, and coordination with law enforcement and emergency management agencies. International coordination of social preparedness became crucial as the disclosure timeline compressed. Different cultures and societies would likely respond to first contact in different ways, requiring culturally sensitive approaches to public communication and support that respected diverse values and belief systems. Dr. Maria Santos, an anthropologist specializing in cross-cultural communication, led efforts to develop culturally appropriate first contact communication strategies for different global regions and communities. Her work addressed the challenge of conveying complex scientific information about extraterrestrial contact in ways that were accessible and non-threatening across diverse cultural contexts. Santos' analysis revealed that effective first contact communication would require multiple different approaches tailored to different cultural frameworks for understanding the universe, humanity's place within it, and appropriate responses to unprecedented situations. Western scientific rationalism would provide one framework, but religious and traditional cultural perspectives would require different communication strategies. The cultural analysis also addressed potential conflicts between different human groups over appropriate responses to extraterrestrial contact, disagreements about contact protocols, representation, or technology sharing could create international tensions that might complicate unified human response to first contact. These concerns reinforced the importance of inclusive, internationally coordinated approaches to first contact that demonstrated respect for cultural diversity while maintaining effective coordination of human responses. The challenge required balancing unity and diversity in ways that strengthened, rather than fragmented, human civilization's response to contact. The psychological and social preparedness efforts ultimately aim to ensure that first contact would strengthen rather than weaken human civilization by promoting adaptation, cooperation, and positive engagement with the opportunities created by extraterrestrial contact. This goal required unprecedented cooperation between multiple disciplines and institutions to address challenges that transcended traditional boundaries between academic fields and policy domains. As 2026 began, Aotearoa had become visible to amateur astronomers worldwide, appearing as an unusual star-like object moving slowly against the background of distant constellations. The International Consortium's careful observations revealed that the object was approaching its final phase of deceleration, apparently preparing for insertion into a stable orbit within the inner solar system. Dr. Park's trajectory analysis indicated that Aotearoa would reach its closest approach to Earth in early April 2026, passing within approximately 30 million kilometers closer than the planet Mars during its nearest approach. However, the object's continuing deceleration suggested it might not simply fly by Earth but rather establish a long-term presence in the inner solar system. The deceleration patterns observed over the final months of approach provided the clearest evidence yet of sophisticated propulsion and navigation capabilities. The object was making precise adjustments to its trajectory and velocity that would be impossible for any natural object, demonstrating active control systems with performance far exceeding human spaceflight capabilities. These final course corrections appeared designed to achieve a specific orbital configuration relative to Earth and the Sun. Rather than following a simple flyby trajectory, Aotearoa seemed to be positioning itself for extended observation or interaction with Earth's vicinity. The implications of orbital insertion were profound. A simple flyby might represent a brief reconnaissance mission, but establishing orbital presence suggested longer-term intentions that could range from extended observation to preparation for direct contact with human civilization. As the object's intentions became clearer, the International Task Force faced increasing pressure to complete preparation for various contact scenarios while managing public disclosure of information. Hat could no longer be contained. Amateur astronomers and independent researchers were beginning to detect some of the anomalous characteristics that had led to conclusions about artificial origin. Dr. Chen's original discovery had evolved into a global phenomenon involving thousands of observers, hundreds of professional researchers, and dozens of government agencies. The scale of investigation and preparation had grown beyond anything previously undertaken for first contact, yet the ultimate nature of Aotearoa's mission remained unclear. The communication efforts led by Dr. Petrov had continued throughout the object's approach, with increasingly sophisticated exchanges suggesting mutual recognition and gradual establishment of communication protocols. However, Aotearoa continued to avoid providing explicit information about its origin, purpose, or intentions beyond demonstrating intelligence and apparent peaceful intent. The final weeks before closest approach saw intensified communication attempts as the reduced distance improved signal strength and reduced transmission delay. The object's responses became more detailed and appeared to incorporate increasingly sophisticated understanding of human language, mathematics, and scientific concepts. However, the communication remained frustratingly one-sided regarding the most important questions. Aotearoa demonstrated impressive learning capability and apparent willingness to engage in mathematical and scientific exchange, but provided no clear answers about why it had come to Earth or what it intended to do during its visit. This communication pattern suggested deliberate restraint that might reflect caution about premature revelation of intentions, adherence to some form of contact protocol that required gradual engagement, or assessment activities that were still ongoing as the object prepared for closer approach. The public disclosure situation became increasingly complex as media attention intensified and speculation about the object's nature spread through social media and popular culture. The careful scientific language used in official statements had failed to contain growing speculation about extraterrestrial origin and government cover-ups. Dr. Williams convened a final meeting of the International Task Force to determine disclosure strategy for the remaining weeks before closest approach. The meeting brought together scientists, diplomats, security officials, and communication specialists to address the challenge of managing first contact disclosure in an environment of intense public interest and media scrutiny. The consensus emerged that controlled disclosure was preferable to allowing uncontrolled speculation to dominate public understanding. Plans were finalized for a coordinated international announcement that would confirm the artificial nature of AO2O24A while emphasizing the peaceful characteristics observed during its approach. The announcement strategy aimed to prepare the public for potential direct contact while avoiding panic by emphasizing the object's apparently peaceful intentions and the extensive preparation undertaken by the international community. The disclosure would occur in phases, beginning with confirmation of artificial origin and progressing through detailed discussion of observed characteristics and communication attempts. However, events outpaced the planned disclosure timeline. On March 15, 2026, amateur radio operators detected structured radio emissions from AO2O24A's direction that clearly represented artificial signals rather than natural radio sources. The signals contained mathematical patterns and repeating sequences that were obviously the product of intelligent transmission. The radio detection provided the first unambiguous public evidence of AO2O24A's artificial nature. Amateur radio communities worldwide quickly confirmed the transmissions and began analyzing their content, making continued official silence about the object's true nature impossible to maintain. The task force activated emergency protocols for immediate public disclosure, recognizing that delaying announcement would only fuel conspiracy theories and undermine public trust in official information. Within hours, space agencies worldwide issued coordinated statements confirming that AO2O24A represented humanity's first confirmed contact with extraterrestrial intelligence. The announcement emphasized the peaceful nature of contact observed to date, the extensive international cooperation in studying the object, and in ongoing preparations for potential direct contact as AO2O24A completed its approach to Earth. The statement included assurances about safety preparations while acknowledging the historic significance of the discovery.